Precalculus Pre-AP 2019 sample problem, semester 2. Last night I made a Precalculus 2019 sample problem, semester 2 one, but this is going to be the Pre-AP version, which will cover the same content, but with a bit more of degree of difficulty. So again, like the last one, this could be 21 problems, and I encourage the viewer to not do all these problems in this hour-long video in one sitting. Work one or two or three at a time. Give your attention span a fresh reset, and try to work out the problem before you actually watch the video of me doing the problem to better understand what's going on and remember. So let's go over these problems. The first one, hyperbola has vertices at 2, -5 and 2, 3. The slope of one asymptote is -1/2. What is the equation of the hyperbola? Now, I've only recently started going over the conic sections, and what we can do is just look by orientation. We have the same x value in each case, and so what that means is just drawing a quick little sketch of what's going on. We have our vertices at 2, -5. So here's 2, -1, -2, -3, -4, -5. So there is a vertex down below, and also at 2, 3. So 2, 1, 2, 3. So here would be our vertices, meaning that the hyperbola is going to look something like this. Okay. And so this is one of the slope of one of the asymptotes is -1/2. So this slant asymptote right here would have to have a slope of -1/2. That's what that means. So now let's go ahead and try to locate the center of this. Well, the center is going to be halfway between these two y values. So if we take 3 minus -5, we're going to get 8. So our transverse axis is 8 apart, meaning our semi-transverse axis is going to be 4. Okay, so here we have 4. So there we go. That's going to be 4 here, and this is going to be 4 here. And they add up to 8. Okay, this center is really important because that center of our hyperbola is going to be the point H, K. And so the standard form of a hyperbola, I'm going to go to our ACP formula chart right here. The standard form of hyperbola is this one right here, or this one right here. And I think this is a y-oriented hyperbola. I'm going to check using the calculator just to be sure. Let's go with that. I'm going to go show where that is. So we go to Menu, Graph Entry Edit, Equation Templates, and we go to Hyperbola. It says East-West is North-South. Well, North-South is going to be y over, minus. So y over a squared minus x. So y minus x should be our vertically oriented. So y minus x. So I'm thinking the y minus x is going to be, make sure I got that right here. Go back here. Yeah, north-south. Y minus x. See the way on the left that icon is? So already we've eliminated C and D. Now, the other answer choice, let's see, we got H, K. So we're going to have y minus 1. And so, but the standard form is going to be y minus k squared over a squared minus quantity x minus h squared over b squared, and that would be equal to 1. And to get minus k, k is negative 1, so if k equals negative 1, then y minus negative 1 is going to be equal to y plus 1. So we want y plus 1. That's going to be this guy right here. See that? And our semi-transverse axis is 4, and 4 squared is 16. So B right now is looking pretty good. The last thing I'm going to do is just verify, just find what that, if we can verify with one last thing, this slant asymptote. So let's go back here and finish this. So we go here to this one here. It says y minus negative 1, and we're going to be over 4 squared. And then up here we have x minus 2. And then we have over here, that's going to be 64, which is going to be 8 squared. So we put 8 right here. And then we graph this, and this is what we get for our hyperbola. And now we're going to get our asymptote. Control, analyze graph, analyze conics, and we're going to look at asymptotes. And here we have, you see this one, y equals negative 1/2 x. So that is going to be it. All verified. B is our correct answer. Next, problem 2. An ellipse centered at the origin has a vertical major axis of 12 units. And so what that means is we're going to have, we want to find our semi-major axis. Is going to be equal to half of our major axis, or 6. And so that means that 6 squared equals 36 is going to have to be underneath the y. Okay, well, that's going to be C or D. Boom, boom. Okay, and now we're given our eccentricity. So we're really between these two at this point. And eccentricity, there's a formula for an ellipse. Okay, let's look at that eccentricity formula. E equals C over A. Okay, and then we'll explain what this is. Okay, C squared equals A squared minus B squared. Okay, and then if we have C over A, well, if we take A squared, if we take answer choice, let's take answer choice A. So if we have 144 minus 36 equals 108. So our eccentricity is going to be, oops, wrong thing. Eccentricity for an ellipse is, I don't even see it there for an ellipse. That's going to be for hyperbola. So we're going to depend on our calculator for that eccentricity. Okay, let's put in. Oops, I got the wrong one here. I meant to take C and D. Anyway, we're going to just get, I'm going to do the first one, x squared plus y squared Okay, x squared over 9 plus y squared over 36. Let's go here and Control I, graph, menu, graph entry, edit, equation templates, ellipse, center form. Okay, let's look at this. We'll try answer choice C first. So we're going to get x, it's centered origin, so x minus 0, y minus 0. That's easy. Then down here, under the x, we have 9, which is going to be 3 squared. And under the y, we have 36, which is 6 squared. And we press enter. And now we're just going to check for eccentricity. We can see our major axis is 12, so that verifies what we've already determined. Let's go ahead and take, that's vertical. So let's go ahead and do our analysis on eccentricity. We go to Analyze Graph, Analyze Conics. We go to eccentricity, and we get 0.866. Well, we want an eccentricity of 0.5, so that's not it. Let's go ahead and try the other equation. To do that, we're going to have x squared over 27. So let's just say we have to put here square root of 27, because that's not, 27 is not a perfect square. Oops. That's not what I wanted. I want 20. Okay, I want 27 in here. Square root of 27. I hope we don't get an error there. It should be there, right? Okay, let's try it now. Square root of 27, squared, that looks better. And over here, that's still going to be 6 squared, so that'll be fine. Press enter. That's what we get. Now let's check for eccentricity. That is it. Okay, we just put our hand over it. So our eccentricity is 0.5. So that's going to be our answer choice D. So kind of a combination of understanding ellipses, using our formula chart, using our graphing calculator. We could have gone with our graphing calculator and just started typing these in and seeing which one worked too. For the polar coordinates, the point 2, comma, -2. Well, our polar coordinates are, we can find R, or X is equal to R cosine theta, and Y is equal to R sine theta. That's that song we've been singing all semester you're tired of. Our cosine is X and our sine is Y. So we can just use this. We can use our formula here and find X and Y. We don't know what R is from this right here, but we could try the different angles. We could work backwards. What I have right here in my calculator, I'm going to go to this kind of page, is my calculator is in radians. So I can choose these answer choices and just type them in radians, or if I'm in degrees or want to be in degrees, I can convert all these polar coordinate pairs into degrees. So this one right here, for instance, in degrees would be 4 square root of 2, comma, 7 pi over 4 is going to be 315 degrees. All right. This one here is going to be 4 square root of 2, comma, 3 pi over 4 is going to be 100 and 35 degrees. And 7 pi over 4 is going to be, so you have 2 square root of 2, comma, 315 degrees. Finally, we have convert into degree form, 2 square root of 2, comma, 135 degrees. So we'll just try these out. And so we want 2 comma negative 2. Well, for that, we would have to have an x positive and a y negative. And so we're not going to see that at 135 degrees. That would be negative positive. So we know it's going to be one of these two, either A or C. So we can try that. For our cosine is x, we said if r is 4 square root of 2, I'm going to try 2 square root of 2. I think that's what it is. So 2 square root of 2 2 square root of 2, which is r, times cosine, and I'm in radians. I could use 315 degrees, which is a conversion. I got to use a degree symbol. So we get 2, okay, so that's going to be our cosine. And I'm going to do the other one in radians. So that's going to be x value. Our y value is going to be 2 square root of 2 times, oops, come outside here, times sine. And I'm just going to put in, and leave it in radians here, 7 pi over 4. Get negative 2. So we get 2 comma negative 2. Is that what it is? Yeah, 2 comma negative 2. So it's going to be this guy right here. Next, 4. Which graph represents the curve given by the parametric equations? X equals negative 2t squared plus 1, and y equals 2t minus 3 over the interval from negative 2 to 2. Well, what happens is these arrows here will go in the direction of time. Let's look at the direction of time here. We got to go, the arrows, if we look at this, we got to go from negative to positive. So here the arrows are going in the wrong direction. A cannot be right. Okay, B, we're going from negative 2 to 2, so that could possibly be it. C, we again, like choice A, we're going in the wrong direction. We got to go from lower to higher in time. So that is that. So really we're between B and D. So let's check out what they are here. And we go to our calculator and Control I. We're going to add graph, menu 3, 4, parametric. We're going to put in negative 2t squared plus 1. So that's x equals negative 2t squared plus 1. All right, and y is going to be equal to 2t minus 3. And we are going between negative 2 and 2. So from here, it should be really easy to find out what it is. So negative 2 to 2, press enter. So we have this looking thing, which could be C or D. So it's going to be a matter of seeing which way the arrow is actually going. And to do that, if we go to menu trace, graph trace, here we are, and we have time equals 0.131, And as we go to the right and time increases, we see which way we're going. The arrow's going up and to the left. Okay? Where do we see that? Arrow up and to the left looks like this one here. So that's going to be answer choice B for problem number 4. Okay, next. Let's go to 5. If a plane intersects a double nap cone parallel to the slant height of a cone, what type of conic section is formed? Okay, what you have here is you have your cone. Your double nap cone looks something like this. And then up above, we're going like this. And when you take a slice that's parallel to the slant height, you're going to come like this. It's going to show up on the other side. When you cut through, it's going to look like this and is going to be a parabola. So 5 is A. And then you just have to know the other things. The hyperbola, choice D, is going to be this kind of section. There's the vertical, perpendicular to the base. A circle is going to be a horizontal to base slice. An ellipse is going to be slanted about like this to create an ellipse here. So that's it. 6. Point P is rotated 210 degrees counterclockwise around a circle with diameter of 20 meters. Now this is just perfect. It's much easier than the one we did earlier here, okay? Than 3. Much easier because it's x is equal to r cosine theta and y is equal to r sine theta. So x is equal to, and we're given our r, and what is our r? R is equal to diameter over 2, so our radius is going to be, oh, my pen is getting glitchy, okay, 20 over 2, which equals 10. So x is equal to 10 cosine of our angle in standard position. That's definitely 210 degrees. So that's going to be our x value. Our y value is going to be 10 sine of 210 degrees. So we can just go here in our calculator. So 10 cosine 210. We're calculators in radians, but we can put a degree symbol here. So we have that, negative 8.66. And then we have y is equal to r sine theta, theta being 210 degrees. So we get negative 5. So our y coordinate is negative 5, our x coordinate is 8.66. The only place I see a y coordinate of negative 5 is A. Now this other one here, if we take negative 5 times square root of 3, what do you bet we're going to get negative 8.66? Negative 8.66. Answer choice A. 6 is A. Should have been a very easy problem. To me, much easier than 3, the one that was like that. 7. What is rectangular form for the curve given by parametric equations? X equals t squared plus 5t minus 1 and y equals t plus 1. Well, here our answer choices are all given in terms of x. So in class, what we did, just about all the time I remember, is we solved for x first and then substitute in for y. Here, we're going to substitute in for y, we're going to solve for t. So if y equals t plus 1, subtracting 1 from both sides, t is going to be equal to y minus 1. And then we can take this minus 1 and substitute it in for t here and also t here. And when we simplify, we should get our correct answer. So putting this in place, we have x is equal to quantity y minus 1 squared plus 5 times y minus 1, and then we have minus 1. So x is equal to, and squaring this thing here, we get y squared, and we have minus 2, negative 1 times, so minus 2y, and then negative 1 squared is going to be plus 1, and then we have plus 5x, and then 5 times negative 1 is minus 5 minus 1. And if we simplify all this out, except I put the wrong thing in there, right? It should be y. It's not x, that's y. 5y minus 5 minus 1. There we go. Now that looks better. That's supposed to be a y here. Okay, for that we get y squared, and then combining terms we have negative 2y plus 5y is going to be plus 3y, and then we have 1 minus 5, or we could say this 1 and negative 1 will cancel each other. We're left with minus 5. So our correct answer in this instance is going to be answer choice D. One way you could do this is use your graphing parametric equations and graph these parametrically, the parametric equations, see what that looks like, and then separately graph this. Now you have to use your graph relation to do that. It won't be as easy to graph, but could be done comparing. But this is the way I did it, I believe, efficient way to do this problem. Next, we have if A equals a vector negative 6, comma 12, comma negative 9, B equals 2, comma negative 16, comma 18, C equals 28, comma negative 14, comma 3. What is 1/3 A minus 3/2 B plus 2C? So we could say, we could just work this out together. So 1/3 A is equal to 1/3 of this vector here, which is negative 6, comma 12, comma negative 9. And what is that going to be equal to? 1/3 of negative 6 is going to be negative 2. 1/3 of 12 is going to be 4. And 1/3 of negative 9 is going to be negative 3. Okay, and then next one we're going to have is 3/2 B. So 3/2 B is equal to 3/2 of this vector here, which is 2, comma negative 16, comma 18. And what is that going to be equal to? We're going to have 3/2 of 2. Well, 2's will cancel each other, so we're going to get 3. And next we're going to have 3/2 of negative 16. So I'm going to do this down below. 3/2 times negative 16 is going to be 3 times negative 16 is going to be negative 48 over 2, which is negative 24. So I'm going to put negative 24 here. And then I'm going to want to use that space. I'm going to erase this here. Then we're going to have 3/2 of 18. So 3/2 of 18. So what you can do is you can take 18 divided by 2 or 9. So we get 3 times 9 which equals 27. So we have 27 here. Okay, and the last one we're going to look at is 2c. So 2c is going to be equal to 2 times 28, comma, negative 14, comma 3. And for that, we get 2 times 28 is going to be 56. And 2 times negative 14 is negative 28. And then we have 2 times 3 is 6. So we're going to have, what that is, it's the first one minus the second one plus the third one. So negative 2 minus 3, that's going to be negative 5. Negative 5 plus 56 is going to be 51. And based on that, we know our answer choice should be A. Let's verify to be sure. So this next one, we have 4 minus negative 24. That's going to be 28 minus 28. We get 0. And then the last one, we're going to have negative 3 minus 27. That's going to be negative 30. Negative 30 plus 6 is negative 24. So our answer choice here is A. 8 is A. Next. 9. A kicker in a football game attempts a field goal 50 yards from the goalpost. The ball is on the ground and kicked at an initial velocity of 81 feet per second, an angle of 66 degrees. The height of the crossbar is 10 feet. We worked several problems like these as parametric equation sports problems. One thing I noticed right away is a unit discrepancy. We have the field goal that's attempted 50 yards away, so we got to change that into feet. So 50 yards times 3 feet per yard is going to be 150 feet. So that's how far that kick is going to have to go. And now we can just write our equation. We're going to have x is equal to 81 cosine 66 degrees, and that's going to be t. Y is going to be equal to, we're starting balls on the ground, so that's going to be 0 plus, we're going to have 81 sine of 66 degrees t minus 16t squared. Where do we get 16t squared? I've explained it a lot in class, but just to remind, if we go back in our ACP formula chart to, is it here? No, it's not here. Here it is. Projectile motion. If gravity is 32 feet per second, we go ahead and substitute in for g over here. If we take negative 1/2 of 32, that's going to be negative 16 t squared. So that's where that thing comes from. So now we're going to go to our calculator and see what's going on here. And to do that, we're going to go Control I, add graph. We're going to graph parametric. 4. So we have for this one, just looking at my notes here, we have 81 feet per second. That's different. It could be. So 81 cosine 66 degrees. And in this, you're going to have to put your degree symbol everywhere because in graphing, the default will be radians anyway. So I put times t. And then down here below, we have 81 sine 66 degrees. And that's going to be also times t. And we're going to have minus 16t squared to have gravity return that thing to Earth. I'm going to go down and readjust this 0.13 to 0.031. It just seems to work well. And so we're going to trace the kick to 150 feet away and see where it is, assuming it's straight. So here's what the kick looks like, unadjusted. Let's go ahead and adjust our window for viewing window. And we go to window zoom, window settings, X min -10, that's cool. X max, I want it to be at least 150, I'll make it 160. And height, maximum height, I don't know if 50 feet is high enough, probably. I'm going to go ahead and press tab down here. And so it really wasn't high enough, but we can still graph even if it's not high enough. So let's just trace. So it's going to go over 50. That's a pretty high angle kick. A real world kick would be a more shallow angle than I believe. Let's go ahead to our menu and trace. Graph trace. And one drawback of having 0.031 is you have to go a long ways here. Okay. But what you get out of that's good is you get better resolution with that smaller increment of time. So we're going to be able to do quite a good analysis. And so what we're looking for is this X value to get to 150. Okay, what's going to happen to our Y value when the X value is 150? Okay, we're over 130 right now. And we're going to get a real good view. So what am I on? There we are at 150. Well, at 150, we are at 4.73 feet. We have to clear a crossbar, we have to be 10 feet above the ground. So we are not, this kick isn't going to make it. It's going to fall short. And it's just going to fall like about 5 feet short underneath the crossbar. And so the ball is not good. The ball does not hit the crossbar. The ball does not hit the ground before reaching the goalpost, right? Because it's not negative, but it's like 4.73. The ball passes under the crossbar by about 5 feet. So that's why our kick is not good. Next problem. What is the exact value of tangent -14 pi over 3 if it exists? Well, we could convert this to degrees if we want to. But I'm going to say, okay, my calculator's in radians, so I'm just going to say tan -14 pi over 3. So tan of, oops, -14 pi over 3. And I'm in radians, so I don't have to convert to degrees. So I get 1.73. 1.73 is square root of 3. It's not negative, not undefined. So square root of 3 is going to be our answer here. Okay, square root of 3, 1.73. So our answer is C. That should be a real easy one. Next, a free response problem. In angle ABC, measure of angle A equals 32 degrees. Measure of angle C equals 110 degrees, and side C equals 750 degrees. So we should see that we have a known side opposite a known angle. And so that's going to be a law of sines application. So I can put 750 over sine of 110 degrees, and that's going to be equal to measure of angle A, which we do not know, over sine of 32 degrees. And we can cross multiply, so we can have angle A is equal to, and that's it's big A. Well, it's going to be side A. We're looking for little a, right? Yeah, little a. So we're going to have 750 sine 32 degrees over sine of 110 degrees. And then we're going to be to the nearest hundredth. Okay, so we've got to watch out for that. So it'll be 2 decimal places after the 2 places after the decimal point. So 750 sine 32 degrees. Got to use my degree symbol here. So I'm in radians over sine of 110 degrees. So that's what you get. So looks like the 100th place, 422.946. That'll be 0.95. That's 6 thousandths. We'll round up to the next 5. So we'll say 422.95. So now we can enter this over here in the griddable, 422.95. So here's our 4, here's our 22, and 0.95. Here's our 9, and here is our 5 right here. Okay, let's go on to the next one, 12. An airplane flies east for 200 miles before turning 60 degrees south and flying for 100 miles. What are the magnitude and direction of the airplane from its starting point? Well, here we have, I like to draw these out, XY coordinate plane. So we could say this to the left is going to be our west. This to the right is going to be our east. And so we know we're flying east for 200 miles. So here we go directly east, 200 miles. So that's going to be 200 in that direction. And then it says turning 60 degrees south and flying for 100 miles. So here's south down here, and we're going to turn 60 degrees, which is going to be like kind of like this. That's 100 miles. So that'll be 60 degrees right here. Okay. And it says, what are the magnitude and direction of the airplane from its starting point? Well, what we're trying to do is find the magnitude and direction of this guy right here. This thing right here, and that's going to be 100. That's 200. That's 60 degrees. One thing we can do is, we got different ways of doing it. We can add vectors together. To do that, we can say, we can use law of cosines. This is 60 degrees. So if that's 60 degrees, 180 minus 60, this is 120. So we can find our magnitude by using our law of cosines. That'd be pretty easy. Then we can use law of sines to find this remaining side. But I'm going to use the vector version. I'm going to say this one right here in vector form is going to be 200, comma 0. And this one down here, this 100, we're turning 60 degrees to the south. So we're going to say this 100 is going to be 100 cosine, and in standard form, well, it's going to be cosine of negative 60 degrees, right? Because that's going to be our x value, and our y value is going to be 100 sine of negative 60 degrees. And what that means when we add these together, we're going to get, I'm just going to write out a big vector here, we're going to get our x value is 200 plus 100 cosine negative 60 degrees. And our y coordinate is going to be 0 plus 100 sine of negative 60 degrees. So we can just put that in our calculator. $200 plus 100 cosine of negative 60 degrees, and I know that's going to be 250, I believe, if I got this right. Yeah, 250, because I know cosine of negative 60 degrees is 1/2. That's going to be 250, and for the other one, we're going to have 0 plus 100 sine negative 60 degrees, and this one's going to be negative, and that's going to be negative square root of 3 over 2 times 0 degrees. So we're going to get negative 88.6. So we get, I'm going to put it right here, 250 negative 88.6. And so our magnitude is going to be this thing right here. We'll have 250 squared plus negative 88.6 squared, and we can get that pretty easy. We go to our calculator, say 250 squared plus, now we got to, with negative signs, be careful about parentheses, because I'm going to put control A and S, because that's the last thing calculated. We have that up there, squared. Oops, wrong one. Squared here, there we go. So we get 264.6. Yeah, so it's going to be either answer choice D or answer choice B. A and C are gone. Now for direction. Okay, direction is going to be theta is going to be equal to inverse tangent of y over x. So we're going to put negative 88.6 over 250. And that's going to be in radians, because my calculator's in radians, but we can convert to degrees easily, so let's do that. We have inverse tangent of negative 86.6 over 250, and I know we're in radians. Convert to degrees, we multiply by 180. Oops. 80 over pi. So we get negative 19.1 degrees. That's going to be this one here, B. East, then this is going to be 19.1 degrees. Okay, and this one right here is going to be a magnitude of 264.6. Right, that's going to be 12. Next, 13. Which angle has a negative sine value and negative cotangent value? You can convert all these to degrees if you want to. I don't know if you remember in class, I had this, if you draw a circle here, like a unit circle, we had this all students take calculus. So your negative sign value is going to be there all in sign. So negative sign value is going to be these two quadrants here, 3 and 4, and negative cotangent value is going to be these two quadrants here. Okay, positive cotangent value, negative cotangent value. So quadrants 2 and 4 will be our negative cotangent value. So it's right in here where I've just put X to mark the spot. So we can see which angle that is. And if you work these out, 9 pi over 5 is going to be your answer. And how do you find that? If you take 9 pi over 5, and it won't be on our unit circle because it's an odd fraction. I mean, just not a common fraction. If we multiply by 180 over pi, so we're going to get 9 times 180 over 5. So 234 degrees. 324 degrees. Being dyslexic there. So that's going to be answer choice D. 13 is D. Next, 14. From the top of a 500-foot cliff, a hiker looks down a river below. Her angles of depression to near and far banks of the river are 75 and 50 degrees respectively, as shown in the picture. Based on information of approximately how wide is the river. Well, we should know that this little piece here is going to be 20 degrees, right? That's going to be 20 because it's going to be 90 minus. And this piece here that I'm drawing in purple, that's going to be 40 degrees. So what we're interested is this triangle here, this side of the triangle here, minus this side I'm drawing in red here. We will get the width of the river. And so for the big one, we will say, we can call this little one y, and in purple I'll call this distance here, the river plus y, we'll call it x. So we say that x minus y is a river. So we say tangent, so tangent 40 degrees is going to be equal to x over 550. And then down below here, we'll say tangent of 20 degrees is equal to y over 550. And we can just work these out. So y is going to be 550 tangent 20 degrees. Oops, not 550 times tangent 20 degrees. Use the degree symbol. So 200.2. Okay, so there's 200.2. Okay, and the next one, we're going to have 550 tangent 40 degrees. And for that, we get 461.5. and that's going to be equal to x. And down here we have this 200.2 is equal to y. And so we want x minus y equals 461.5 minus 200.2 My pen is really kind of glitchy today, so that's going to be 261.3. Yeah, it's going to be answer choice C. That really shouldn't be that hard of a problem, but you have to set it up and kind of go through it methodically. You could have used cotangent also, but I think this is probably the way I did it. That's the way I like to do it. Next, 15. Two forces act upon an object as shown. What is the approximate magnitude of the resultant force? We did one very similar to this during class, and I want to show you here. We're going to have, this is kind of like the airplane one. We're going to have our first one, our 15 pounds. So we get 15 cosine of 20 degrees, and then we're going to add our other component from this 12 plus 12 cosine negative 27 degrees, because we're rotating down, comma 15 sine 20 degrees plus 12 sine negative 27 degrees. So we can just put this in our calculator and get those components. Let's get this equals. So we're going to put this 15 and 12, yeah. So 15 cosine, we have 20 degrees plus 12 cosine negative 27 degrees, and so we're going to get an x value out of that, 24.78, and the y value we're going to get is 15. I think what's going to happen is the sines are going to cancel each other. Sine 40 degrees or 20 degrees. Plus 12 sine negative 27 degrees. So that's going to be it. So very negligible. So if we go ahead and take this whole thing, we put 24.7875 squared plus, we're going to put ANS here because that's the last thing calculated, squared, we're going to get a net force of 24.79 feet, 79 pounds. Okay, I would just put magnitude 24.79 pounds. LB, you know, I put the LB for abbreviation for pounds. That's because in Latin, I think libra is a Latin word for pound, so LB is kind of stuck. So 15 is B. Next, we go to 16. The co-vertices of an ellipse are at negative 2, 1 and 8, 2, and the eccentricity is 12/13. What is the equation of the ellipse? Again, like I did earlier, I recommend drawing a little picture here. So if I draw a little XY coordinate plane, so here's my XY coordinate plane. So here's X, Y, and we have -2, 1 for one vertex, and then we have 8, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8, 1, and so our ellipse is going to look like this, somewhat. And we know that it's going to be a horizontally oriented ellipse. That's an ugly looking ellipse. Not a whole lot better, but somewhat better. Because we're along the y-axis. So what that's going to mean is if we have 8 minus -2, it's going to equal 10. That equals our major axis. So our semi-major axis, okay, is 10 divided by 2 is equal to 5, equals semi-major axis. So that means we're going to have x squared divided by 5 squared, which is 25. So A is gone, D is gone. Now if we locate the center of the ellipse, let's see, we got halfway between 8 and -2 is going to be 3. So this is going to be our center of our ellipse. It's going to be 3, 1. So we're going to get x minus 3 squared plus y minus 1 squared. X plus moves to the left and x minus to the right. It's going to be C, just based on that. And we're just going to test one more thing for the calculator. Just put it in the calculator here. Graph it to be sure about our eccentricity. Control I, add graph, go to menu, graph entry edit, equation templates, ellipse, center form. So we're going to have x minus 3 over 5 squared, come up over here, y minus 1 over, and that was answer choice C, so that was 169, that's going to be 13 squared. So let's go put in 13, graph this. Yeah, it kind of looks like a vertically oriented ellipse, isn't it? But let's go ahead and check our eccentricity. That doesn't look right at all, does it? But I guess it is. Okay, let's go check our eccentricity, go to menu, analyze graph, analyze conics, eccentricity, 12/13. Yes, that's it. So that's verified. That is our correct answer, C. That is a weird looking ellipse though. Okay, let's go into 17. During a scouting exercise, Andres leaves camp and hikes 2 miles northwest. He turns and hikes 3 miles due north. Felicia leaves camp and directs. So we're going to be looking at so I'm going to draw kind of an XY coordinate plane. It's going to serve for the north-south thing. So here's going to be our east here. Here's going to be our west over here to the left side, and north is going to be up here. So Andres leaves camp and hikes 2 miles northwest. So that's going to be exactly between north and west. That's going to be 2 miles. Okay, that's 2. So we know that's going to be 45 degrees. He turns and hikes 3 miles due north. So here's another 3 miles north. And so what direction and distance Felicia should take. So Felicia is going to be going straight through like this. I'm going to draw from here. So this is Felicia, what I'm trying to draw here in blue. So Felicia's going to go straight. Well, we should know that already Felicia's going to go less than 5 miles. And I'm thinking it might be this one right here. Okay, direction. I think it's going to be this one right here, because here's the direction. But we can go ahead and figure out what it is. So it's going to be, okay, that'll be 2 cosine of, that's going to be 135 degrees plus 3 cosine of, we're going straight north, that's going to be 90 degrees. Well, cosine of 90 degrees is 0. And comma, we have 2 sine of 135 degrees plus 3 sine 90 degrees. Well, that's going to be 2. So two cosine 135 degrees plus 3 cosine 90 degrees, and I already know cosine 90 degrees is 0. So we get negative 1.1, negative 1.414. Okay. Next we have 2 sine 135 degrees plus 3. Oh, and I really blew this, didn't I, up here? Because that should be, no, that's right, I did that right. Plus 3 sine, second guess I was right, 90 degrees. We're just going to simplify to 1. So we have that. So 4.41, 1.41, 4.41. Comma 4.41. And we're going to, that's going to simplify to greater than 4.6. Our magnitude is going to be equal to the square root of negative 1.41 squared plus 4.41 squared. We can find out what that is. Squared plus, and I'm just going to use this right here, it's positive, so I'm going to go to Control A and S because it'll give me that, and square this, so we get 4.63. So that's the right distance. So 4.63. So we already know that A and B are incorrect. And then our direction is going to be equal to our inverse tangent of 4.41 over negative 1.41. And one thing that helps us too is that we know that we are in quadrant 2, so we're going to have to add 180 degrees to that. And we're going to get something. So I'm going to go here and put inverse tangent of 4.41 over negative 1.41, and we're going to get this, which is a radians answer. I mean, it's going to be not a, yeah, radians. We want degrees, so we'll multiply it by 180 over pi. So we get negative 72.26. Add to that 180. We get 107.7. Yeah, that's going to be answer choice D. Next, 18. If cosine is 7/25 and tangent theta is less than 0, what is cosecant? Well, cosecant, we can go to our HCP formula chart. Cosecant theta equals 1 over sine theta. So if cosine is positive and tangent is negative, we know that our answer is going to have to be negative. And we can't have a cosecant of less than absolute value 1, so A is going to have to be our right answer, just by process of elimination. B would be a possible answer for sine, but in fact it would be the sine, but our cosine is going to be negative 25/24. Yeah, cosine is going to be adjacent is 7 over our hypotenuse, which is 25. So this thing right here is going to have to, when you work it out, be negative 24. And so our cosecant is going to be our hypotenuse over opposite, and that's going to be, if you work out Pythagorean theorem, you get 25 squared minus 7 squared. Okay, you get 625. I think that is 25 squared minus 7 squared. I'm just going to write what that is. So 25 squared minus 7 squared, so 576. So your opposite is going to be equal to plus or minus square root of 576, which is going to be equal to plus or minus 24, and we know we're going to have to be minus because of this tangent theta being less than 0. A is our right answer. Next, 19. Julissa wants to find the measure of angle A and angle ABC in triangle ABC. She used the law of cosines, worked problem as shown. And so what we're going to have is 11 squared equals 7 squared plus 9 squared minus 2 times 9 is cosine x. Good, and she can find that. Next, you're going to have to simplify. Well, 11 squared is 121, and then 7 squared plus 9 squared simplifies to 130, and then, so that looks good. That's 49 plus 81, that's 130. And 2 times 9 times 7, 2 times 9 is negative 18. Negative 18 times 7 should be 126. That looks good. Next, she's going to subtract out 130. Well, to subtract out 130, she's going to get negative 9 on this side here. I'm thinking going to step 3, that's got to be a mistake, because she should get negative 9, then divide that by negative 126. So I'm thinking step 3. So we will say we found our mistake right here, step 3, because that should be a negative 9. So step 3 is our mistake. So it's just ferreting the algebra out, and then if we did that right, we'd get positive 9 over 126 cosine x. We could find out what that is. We could work that out with our calculator, see if it verifies to our correct answer, and that would be it. 20. Which polar equation produces a spiral of Archimedes? You may not know what that looks like. One thing you could take to graph a polar equation, you have to solve for r. A does not have an r in it. For B, we have to solve for r. R is going to be equal to 2 over cosine theta, which is going to be with reciprocal 2 secant theta. So we could, secant degrees. Okay, this one here, C is going to be r is equal to 2 over sine theta, which is going to be equal to 2 cosecant theta. We graph those, we're going to get lines. But our real answer is going to be D. So let's just go do that, see what a spiral of Archimedes looks like. R, and then we go to menu. We go to graph entry, edit, polar. So we'll put in 2 theta. We get our theta down here. And there we have it. So that's a spiral of Archimedes. See that spiral? That's a beautiful spiral right there. So D is our correct answer. Okay, now our last one, 21. Owen's house is 12 blocks away from the library. Okay, you know what this one is? This is the same as number 19, kind of. Okay, I think the numbers are a little different, but it's the same concept. We want to find this angle right here. Well, do that. We set it up as 9 squared equals 12 squared plus 8 squared minus 2 times 12 times 8 times cosine of x. That's going to be it. And we can set this up in our as our unknown here. We can use numerical solve. We can do like Julissa did with a mistake there in number 19. But I'm going to use numerical solve. This has been a super long video. I want to get this over with. Okay. We're going to go to menu 3.1. Numerical solve, and for that we're going to have 9 squared equals 12 squared plus 8 squared minus 2 times 12 times 8 And we're going to have cosine of x. And what I'm going to do here is I think I can put in degrees to get my answer in degrees. Okay, and then I can put comma x. I think I can get away with this. Just make sure you have things entered right. Law of cosines, enter. So 48.5888. Okay, 48. That's going to be degrees. And we want, what does it say? To the nearest degree. Okay, single degree. So x is going to be equal to 49 degrees according to the instructions here. So we put in 49. We can put these any place just as long as we have the right digits consecutively. And we don't have to put a plus sign because the thing already chooses plus if nothing is mentioned. So we put 4 here and 9 down here. And that's it. So more rigor than the other lesson, but considered together, these two should be very helpful for the test that's upcoming. Good luck, and thanks for viewing.